Good evening, ladies and gentlemen. Welcome to today's discussion and webinar on data science and business analytics. I want to warmly welcome all of you. Thank you for being here today. And we have a very, very exciting session for all of you. And we have with us two distinguished speakers and also a very qualified and experienced panelist, and we are talking about some very, very exciting topics. Firstly, I'd like to introduce the three members with us today. We have with us Mr. Lasitha Petawadu, and he is a software architect at Limark Technologies. Lasitha is also a visiting lecturer and a certified blockchain expert. And he'll be talking to us in detail about big data and why it is so important today. He'll also mention what kind of job opportunities are there with regards to big data, what kind of prospects you will have today, and I'm sure he will also discuss the future. He will take up case studies, or perhaps he will talk in detail about a case study and how this program actually helps to prepare you for that kind of future. Then we also have with us Mr. Dinesh Asankar. Now, Dinesh is a Bachelor's of Science in Electrical Engineering. That's his background from the University of Moratuwa in Sri Lanka, and has an MBA in Information Technology, a Master's of Science in Artificial Intelligence, and a Master's of Philosophy from the University of Moratuwa. Dinesh has over 20 years of experience at various organizations. He's worked at Pearson Lanka, he's worked at Virtusa on data technologies. He was the Microsoft Most Valuable Professional for 10 years in data platform. He is also a visiting lecturer at IIT and the University of Kelaniya, Department of Management of IIT. He is a frequent speaker and columnist on data warehouse, machine learning topics at many popular websites, conferences, and user groups. So, ladies and gentlemen, we have a very experienced and qualified set of speakers today. And in addition to that, we also have with us Dr. Subha Fernando. And we're very grateful for her presence with us. She's the panelist today. And Dr. Subha Fernando is artificial intelligence research scientist. She's also a senior lecturer at the University of Moratuwa. She is the coordinator and co-founder of the Qubits Artificial Intelligence Laboratory of the University of Moratuwa. Now, Dr. Subha earned a doctorate of engineering from Nagaoka University of Technology in Japan. She received her BSc Special Honors degree in Statistics and Computer Science from the University of Kelaniya in Sri Lanka, and received her Master of Engineering in 2010 from the same university. She is the former head of Department of Computational Mathematics and the former Director of Information Technology Research Unit of the University of Moratuwa, and a past president of Sri Lanka Association for Artificial Intelligence. So, ladies and gentlemen, we have a highly qualified panel and a set of speakers with a wealth of experience to add value to us today, right? So it's going to be an exciting discussion. I'm not going to take much of their time because I'm sure all of you are looking forward to hear what they have got to share with us today. So I'm going to pass the mic on to Lasitha, who will talk to us on big data. So Lasitha, over to you.
Thanks, Havindra, for the introduction. So let me first share my screen and let's get started. I hope everyone can hear me clearly.
Yes, Lasitha, you're coming through loud and clear.
Okay, right. So I'll be talking and taking you through the future of data science as well as the different opportunities, as Havindra said, right? So before we move into the future, let's try to take a stroll into the past. So I want you all to focus on these images that you see on the screen right now, right? So if you look at each of these images, these are different actions that people perform, right? So the first image that you see here, it's someone withdrawing cash from an ATM, which is something that we all do. And then you can see someone shopping here. which is something that we do these days quite often because of the Aurdu season and all of that. And you can see a farmer here farming, as well as something related to manufacturing, right? So all of these actions, all of these things have been there for quite some time. We have been performing all of these actions for quite some time. But if you think about it, in the past and how it is today, in the past we have been doing all of these actions, but we have not actually captured the data or the things that are emitted by performing these actions most of the time, right? So if we go back and if we look at some of these things, right? So data has always been around us. We have been having immense amounts of data through our interactions with systems, through our interactions with people, and throughout all of our day-to-day activities like farming, manufacturing, all of these things. But what has changed is humans have found ways of tapping into this data through technology. So let's try to see how we have done something like this. How have we tapped into this data? What is different today than it was in the past? So if we try to see, if we try to look at these images now, right? What are each of these images? So the first one is something very familiar to you. It's a mobile phone, right? So all of us have used mobile phones, are using mobile phones at the moment. And we know very well that a mobile phone is like a revolutionary device that was there, that came into limelight over the past few years. Because of the mobile phone, things have become so much easier, and our interactions with the mobile phones have also become much more, like we have been interacting with it over the years, right? And it's like a staple device that we need to use every day, right? So another thing that stems out of it is social media. So social media, again, all of us know, all of us visit social media, and we go and we post our pictures, we do interactions there, we look at events. Even this particular event you might have seen over social media, right? So all of this data is now being analyzed. People are looking at this data, and the bridge between us and the data is through these types of devices and technology. And then again, if you look at the financial sector, banking, all of these things. So with things like digital currencies, like cryptocurrencies, all of these things coming into limelight, we have found out that there are more ways of capturing users' data as well as getting more insights about the users who are using them. We have tried to look at different buying patterns of users if it comes to retail, and how people are interacting with these retail systems, right? Let's say you're going to buy something, how often would you go and buy certain things together, right? So let's say during these seasonal periods, you would buy certain items together to gift people. So all of this data gets accumulated and captured. But what is different is in the past, we never looked at any of this data, right? But now people are focusing more about this data so that they can derive meaningful insights. Then again, you might be wondering what this image is. The image with a toy car. So the toy car with batteries and all of this. So this is again related to different types of IoT devices and different types of devices that are used in robotics. So these types of devices again will allow us to do things in a smarter way. So if you think about smart farming and using different types of embedded devices, small computing devices, which can capture things around us, environmental factors like the environment, the temperature, the humidity, all of these things, we can make sure that our crops are utilized better. So intelligent farming, smart farming, and all of these concepts go hand in hand with data science. So if the data was not there with us, we wouldn't have been able to do any of these things, right? So I'll be getting into the last image here, the spectacle kind of device, right? So I have a few things along the way that explains why this device is also special. So let's move on. So if you look at the different industries that are using big data heavily, so you can see at a glance, 87% of telecommunication companies are investing on big data, and they are using big data. This is no, like this is very obvious, right? So because mobile devices are are being used by many people, and there are so much of data being generated because of mobile devices. This has become popular, and people have invested more time as well as resources into big data in telecommunications. Then again, financial services. Financial services, again, different e-commerce platforms, different types of financial institutions like banks, all of these things, they also have moved into big data. And then again, healthcare. So you would not imagine, but these three are the top three industries that are heavily using big data. So if you think of healthcare, again, with different types of smart devices, we have been able to detect certain conditions of patients. So we can connect these smart devices. Even your mobile phones these days have different capabilities. It has different types of embedded hardware which will allow to capture different types of data. So imagine if you have an elderly person at your home, and you want to make sure that that person is being monitored and to check his condition, to check whether he has fallen down, whether he's properly being taken care. So you can use these type of smart devices to easily capture such data, right? So this is why it's heavily also being used in healthcare, and there are many types of different use cases that we have based on all of these. But why is big data important? So I think some of the reasons are clear to you all now, right, with the examples that I discussed. But generally, if we take at a nutshell, why do you think is big data really, really important, right? So let's try to focus what are the main key drivers that help that we use when we are discussing about big data, right? So the first and the foremost most important thing is better decision making, right? So in the past, as I told you, we did all of these actions, everything was there, all of our day-to-day activities were the same. But now what we are doing is, by using that data, by utilizing that data, we are converting that raw data into meaningful information, right? So by looking at that data, we can look at different patterns, different types of usage patterns, all of these things together to make better decisions. And the next one is improved products as well as services. So by looking at people's buying patterns, usage patterns, and by analyzing that data, we are able to produce better products as well as give better services to the people who are consuming them. If you take again mobiles as an example, you might have seen mobile phones back then, during the time when we didn't have smart devices, had very primitive set of features. They didn't have much hardware device, like hardware components embedded inside of them, and they did not have a lot of different types of uh, engagement points, as we would recall, right? But now what we have done is, by looking at how people are using them, how people are spending time on mobile devices, manufacturers themselves have captured that data and they have produced better devices. So the way people use mobile phones and how we interact with them, the way we place our hands on the mobile phone, the different agility of our thumb, as well as how we type on different on the phones, all of these factors are being used in order to decide what is the next best product that we can put out to the market, right? So that is how we improve from time to time. And then again, optimizing business processes. So we looked at things external. If you look at improved products and services, that is entirely external. The impact is for the end user or the customer who is getting these products and who is purchasing these products. But if you look at the internal processes, right, the manufacturing process that takes place when developing these products. So one main important point there is to make sure that we reduce wastage, right? We reduce wastage and optimize our process in such a way that we can produce more products and services efficiently. So then again, big data plays a high role there. We can track people's individual productivity. We can track different types of business processes and check how are we performing in each of these business processes, right? So this is why all of these things in a nutshell is very, very important. So what are the practical scenarios? So I told that these are the values, but what are the main practical scenarios that we have that would back each of these things? So I want to show you a few examples around each of these scenarios. So first of all, I told we generally capture data from users, right? We try to capture data from users and we try to make improvements to them. So this is an advert that was published. And in this advert, what they have done is now they are going to advertise baby diapers, right? So they are going to advertise baby diapers. So when they are trying to advertise baby diapers, they want to know how much of people are engaging with this particular post, right? So traditionally what we would use is we would use people who have visited the link, people who have seen this post, those type of options. But what they have done here is they have taken a control group, they have taken a subset of people, and what they have done is they have given them this particular device that I showed before, the device that I showed before, right? The spectacle device. So this particular device, what it has is it has a camera, and it will check where the person's eyes are moving, right? Where the person is looking at the screen when he's viewing this post. So by looking at that, what they have understood is they have created this heat map, and they have seen that people have looked at the baby's face. So the places in red are the places where people have looked at the most. So they have realized that people have looked at the baby's face, but very rarely people have read the post, right? They have not read the post much. So this is actually defeating the purpose, right? So we want them to grasp the content that we have written here, and we want them to go and buy more products based off of what we have posted here. So then again, what they did was they did a slight change to this post, and they did this experiment again. So they changed the baby's face, right? So they turned the baby so that the baby is now looking at this particular post, and they performed this experiment again. And then they realized, okay, now more people are looking at this post, right? So without capturing this data and analyzing this data, they wouldn't have been able to identify how much of engagement is there in each of these posts. So another example is called the jam experiment, right? So imagine you go to a website or a web store, right? And you're going to buy some products. And when you're going to purchase some products on a web store, one of the main things that you would want is to know the options, what type of products are there, right? So if it is maybe mobile devices or maybe different types of electronic devices or something that you want to buy, you would feel that if you're designing this particular website, you would feel that giving all the options to the user at once will be the best thing to do, right? So then they have a lot of options to pick from. This should ideally be the best way, right? So then they can go through everything and they can pick it. But when they carried out an experiment based on this, what they realized was giving more options to people makes their mind paralyzed, right? So the conversions here. So if you look at this, you can see the conversions are basically people buying products by looking at each of the products, right? People who are converting into people who purchased products out of our store. So when you look at this, you can see that 4% of conversions were there when many items were listed. But there were more conversions when we listed few items. So this is quite strange, right? So what they came up was more choices often don't mean more sales or engagement, right? So a popular company who was facing this dilemma was Netflix, right? So they suffered from something called decision paralysis, right? So their initial site looked like this. The initial site looked like this, and because of that, they had all of the movies listed in one single page, and that made people to be like overwhelmed by all the options that were there. So because of this, many were just browsing the movies and they were not actually watching any of the movies, right? So what have they done now? So if you are using Netflix, if you are a regular user, you would see that they have done certain things around this now. So now they have fewer choices and it's more personalized. So you capture more information about the person, and based on the information that you captured, you would go ahead and you would give them the best possible view. So then again, if this data was not analyzed and if it was not captured, they would never have been able to personalize a view and give something like this for us, right? So based on the genre that you are watching, if you are more into comedy movies or if you're more into thrillers or action, based on what you have watched in the past, they would go ahead, make decisions that are impacting your future. So what you're seeing on the screen is always going to be a personalized view rather than giving you an overwhelming view of everything that is available. So these are some of the things that we can do and some of the benefits we can reap out of big data and data science. So then again, if we look at Netflix and if we move into the architecture and the way it's designed, in order to develop and design and capture all of these big data related aspects, they have a huge infrastructure backing them. Most of this infrastructure is deployed on cloud environments. So cloud also goes hand in hand when we discuss about big data. So you can see in this image, so even though we are briefly going to touch base, they have moved previously from a monolithical architecture, everything in one, into a microservice architecture, and they have stream processing, different technologies like Hadoop, and different data storage technologies like AWS S3. So all of these things are there so that they can capture more information from different types of devices like mobile phones, smart televisions, and different gaming consoles. So Netflix is available on all of those environments. So in our big data module also, so during cloud computing, we discuss some of these aspects. We discuss how we can design systems like this, how we can scale systems so that we can capture a lot of data and how we can manage such data in our applications. So I'll quickly move on to different big data prospects and opportunities for you. So since you are interested in this area, what can you do ultimately? What is the ultimate for you, right? So there are different career opportunities and prospects that are available. So if we quickly touch base on some of those, the first one is a data scientist, right? So a data scientist is basically a person who has a good understanding about statistics, who has a good background in computer science, right? And the person who is at the computer looking at data and figuring out different statistical models, machine learning models that will help to derive the insights from the data, right? So these guys are the masterminds of the entire big data platform or big data ecosystem that the organization is building. So they are at the very rootmost level, analyzing the data, looking at how we can derive certain things out of the data. So they need to have an advanced knowledge of different data mining, clustering, regression, right? So all of these mathematical concepts and machine learning concepts are being used, and they go ahead and analyze the data that they get. Then you have the executors or the doers, right? So data engineers. Data engineers are the people who make all of this a reality. So the data scientists will actually build a model, a mathematical model, or some kind of a model on a piece of software. And the data engineer is the one who is going to translate all of these into computer algorithms. They are the ones going to develop all of these things, build a prototype, and put it out into the world so that they can use it. So technologies such as Python, Kafka, Hive, Storm. So people who are aiming to become data engineers should be proficient in all of these technologies. And then you get data analysts. So data analysts are the ones who are engaging with customers. They will conduct different types of surveys. They will go ahead and talk to customers, and they will try to find out different types of data that we can capture and visualize this data and present the data to different audiences. So they are actually working with different BI tools, visualization tools, and they will actually accumulate the data and present this data in a meaningful manner. And then again, you have data architects. Data architects, generally what they do is they have a higher knowledge on data-oriented computer languages, right? So they will use different types of, they have understanding about different types of structured as well as unstructured databases, right? So when you're given a problem, when you're given a real world problem, data architects will look at how this problem can be approached, how the data related to this problem can be mapped out, can be designed, and can be stored. So they will decide, okay, for transactional data, this is the best way, this is the best model we can use to store this data. This is the technology we should use. These are the different schemas we should build. So they have the insight and the knowledge in order to give that design and that architecture for the engineers to go ahead and execute. And finally, you have data managers. Data managers are people who do the administrative work. So they will go ahead and try to diagnose day-to-day issues that are there in databases and these environments that we are operating on. So they will review all of the business data and they will look at all the data sources and try to see whether there are any performance issues, right? Whether we can go ahead and administer and improve the performance of all of these things, right? So that's where they are going to be focused on, right? So I think we captured almost everything that's there. So I did a brief introduction onto what are the prospects. We discussed about Netflix as a case study and how Netflix has become quite emerging, right, in this particular area. And this particular course that we are offering, it allows you to orientate yourself into each of these different types of prospects. So the modules and the things that are there in the course will help you to achieve any of these career dreams that you have, right? So with that, I will wind up. So thanks a lot. So we'll discuss any questions or any doubts that you have in the panel discussion. Over to you, Havendra.
Lasita, thank you so much. That was extremely insightful and very, very interesting to listen to. Thank you so much for presenting that to us. And as you were speaking, the questions kept pouring in. So Lasita, we are not done with you yet. We will be back to you with all these questions very soon. But before we do that, I'm going to ask, actually just going to move things forward. So that was a lot of information about big data and surrounding details, which I thought was very, very interesting. And just judging by just a glance over your questions, I can see that all of you are just as excited about it. But we need to move on, and we'll come back to the questions, ladies and gentlemen. So please keep sending it in. Those of you who want to send us questions through Facebook, you are free to do so. And others, you can send your questions in through the Zoom chat function. And we will take up as many questions as possible, but feel free to send them in. Okay, so we're going to move on to Mr. Dinesh Asankar. Dinesh is going to talk to us about business analytics, right? And without taking any more of his time, and let's move on to Dinesh straight away. So Dinesh, over to you.
Okay, let me share the screen. Okay. Can you hear me, Havendra?
Yes, we can hear you, Dinesh.
Okay, thanks. Yeah. Okay. Good evening to all of you. So business analytics today and future. So that would be the high-level topic for this particular session. So now, first and foremost, what do you mean by analytics? Now, we all do analytics, whether it's home, at roads, or whatever, wherever we do analytics. We take decisions. Now, when it comes to analytics, there can be different types of analytics. Basically, day-to-day life, we do descriptive analytics and diagnostic analytics. What happened and why did it happen? Then, next level of analytics, we call it advanced analytics, is the predictive analytics. That is, we are going to predict the future, what will happen, and we are not stopping there. We are not stopping there. Though this machine will say, okay, there will be rain or whatever, we want to take necessary actions to make it happen or to avoid whatever the predictions are saying. So prescriptive analytics is also part of analytics. So when we are saying analysis, business analytics, nowadays we always confine, mostly in the industry, we confine to descriptive and diagnostic analytics. It's very much few organizations that is going beyond this, right? So to be in the competitive with in the fiercely competitive market today, you need to be the performing your predictive analytics, and also you need to do the prescriptive analytics. So then the question is, from what? Okay, you need to do analytics, but from what? Now, we have been talking about IoT, Internet of Things. Even previous session also we heard few things about Internet of Things. But data is again beyond that. Now, every one of us is data now. We generate data. We need to accommodate those data as well to make our predictive analytics. So then we will have Internet of Content. Content plays a huge role now with advanced technique like natural language processing and text mining. And then, as I said, Facebook, Twitter, LinkedIn, you name it. And now phone is no more a communication device now. It's not, I would say it's not only a communication device right now, right? It's a data device, I would say. So that would also will generate the data. So now again, I go back to the previous slide. So you need to do this analytics on this data. This analytics on this data. So that is where the complexity coming in, right? So if you look at, but in organizations, we might not be doing those analytics yet. You generate a data or some reports, employee report, HR report, whatever. You do basic analytics, mostly diagnose the descriptive and mostly descriptive. You might go into diagnostic analytics as well. Then you stop there. But for futuristic organizations, you need to go beyond that. You need to do better analytics with your data, but you know for a fact that your data is may not be enough to do the predictive analytics. I'll tell you an example. I don't name those organizations because this is a live public event. One of popular pastry shop chain. So they want to predict the sales that they do, so that they can do optimal ordering. So if you look at that particular very simple case study, they sell pastry items. So they want to predict the next day what is the sale of this particular item. Now then, so it depends on a lot of other factors. If your particular shop is close to a school, then the pattern is different. If your shop is close to another film hall or whatever, then your predictive analytics will be different. In school example, your sales might be high on daytime or rather weekday time, but on the second example, your sales might be high on the weekends. So you will see, you can't simply collect the data and do this analytics. You need some thought. You need to put some thoughts into this. Number one. Number two, you need to collect the other data as well, right? Not only your data, but you need outside data as well. So complexity has become a huge challenge. Now, we were here for around 30 minutes now, if I remember correct, if I calculated correctly. Now, at this particular moment, how much data that we have generated? We all, right? I was speaking, some people were sending messages, some might be in the Facebook, all data. We have generated data. So that is why there is this new theme. This theme is not very new theme. The data is new oil came around 10 years ago. If you really look at why this term has a very broader meaning. Now, oil, until you refine the oil, it doesn't have any value. Same with data. You will have huge volume of data which were generated from different sources, but unless and until we analyze them, there won't be any value. There won't be any value. If you look at the most revenue generating organizations today, compared to last decade, or let's say 3 or 4 decades ago. 3 or 4 decades ago, most revenue generation organization were oil, automobile, that type of organizations. But now it has shifted to companies like Amazon, Apple, Microsoft, Oracle, so on and so forth, right? Because now organizations are run on data, right? We saw some couple of examples in the previous session as well, how organizations are using data to make a better service, to give a better service to customers, so that end of the day, they can earn profit. Now, why it is so challenging? So we normally call this as V's in data. You might be in this particular course, you might be learning this V's in different ways. Now, if you look at your organization, you might have large volume of data. Now, don't think that when I say data, it's not the traditional databases that you have. That era is gone. You can do a lot of analytics, yes, but there are more than that. What about your emails? That's also your data. Have we analyzed your emails? Really? You send the chats or whatever to your colleagues. Lot of data. Have you analyzed? Hardly. Right? Images, videos, your documents, PowerPoint slides. These are your data. That's why the variety accepts is coming in. Different types of data. Also, when it comes to your storage data, for application data. Now, earlier, good old days, you have one database, whether it's Oracle, SQL Server, MySQL, or you name it. That's your data. But now, organizations are not keen on storing all data in one place. They would like to use different types of databases, right? Tell you some examples. You have now in the world of databases, you have relational databases on the one line. On the other side, you have NoSQL databases. Under NoSQL, you have document databases such as MongoDB, CouchDB. Then you have column store databases, key value pair databases, graph databases such as Neo4j and GraphDB, time series databases, InfoDB. So their structures, the concepts are totally different, right? So data can be anything now. As I said, videos is your data. So you will see variety of data. Volume, we all know what the volume is, right? Large volume of data. And the velocity, rate of change. In your organization, how rapidly your sources or data is changing. Depending on that, your analytics has to be changed. Analytics have to be changed. Veracity, how do you know your data is correct? Okay, if you have chat messages, there is no the schema or no rules for chats, right? You chat anything, right? You send messages, you send images over the chat, right? So how do you how do you analyze them? Finally, then there are a lot of other V's, right? Very recently I saw an article which says 76 V's. Right? Okay, we don't want to go into that details here. So here what we are looking at is these are the basic V's, and the other 5 I would say much appropriate, if not the most appropriate. So ultimately, we want to generate value out of this data. So as a business analysis, your challenge is to generate value for your organization, right? But things are not very simple because you have these challenges: volume, velocity, variety, and veracity. Right? So you need to look at how you can change, how you can retrieve data, transform it to bring a value to your organization. So this is a data warehouse. I would say around 3 decades ago, if someone asks you what's a data warehouse, 20 years back, this is your data warehouse. You have very simple databases. You bring them in from ETL tools, extract, transform, and load, move into a data warehouse, and then you do the different analysis. Even today, you might see this type of data warehouses. So data warehouse is to analyze your data. So there is a separate module on data warehouse. But today, data warehouse is this. Data warehouse is this. Right? You have different sources, not only storage databases, not only the storage like databases like relational or MongoDB or whatever, right? It can be anything, right? It can be anything which you generate a value out of that, right? And then you transform them, then load it to some dashboards or whatever for a presentable view for a different management in your organization. Now, what are the skills you need? Now, if you look at this diagram, you might think that, okay, you need a Superman to learn business analytics. I mean, let's put that aside and let's see what are the things that you need to learn. So statistics, right? Database algorithms. So we'll be covering database algorithms in the database management lecture. Then then machine learning and data mining. So those will be covered also. Domain knowledge. Okay, so I'll go by one. The large scale distributed computing or cloud, right? So cloud, another area which is a kind of a trending. We will be look at that at a different level. So you will see when it comes to analytics, you need to know different sciences, right? Now, then you might ask, so then do you think this is a correct job? Or so business analysts are people like this who doesn't exist. It's not that. Nowadays we talk about ML ops, machine learning operations, where you combine operational people and developers together, right? So some of these might fall into the operations, like database algorithms and those things might be falling into the operationals, as well as you might need domain knowledge from different people. So in case of business analysis, basically what they do is they bridge these different technologies. You might not need to be an expert on each of these areas, but you need to know how, so that you can bridge these gaps in case of a need. Now, when it comes to, okay, let's say domain knowledge, machine learning, and you need to join that with the domain knowledge, right? Two different areas. Now, business analysis would be able to join these gaps, right? Now, sometimes it might be a different world that you are trying to join, but still, you need to understand. You may not be need to do very high level, what you call expert on each area, but you need to know how about each and every aspects of these areas or sciences. Okay, what's the future now? So data lake. Now you might ask, what's the future? This has been already there. Yes, it is there, data lake. But the thing is, still it's more likely a storage environment. More, I mean, honestly, I don't see. I haven't seen people are using for analytics. People are not using a data lake now. What they mostly do is they simply gather data into the data lake, and then they use different mechanisms or different operations to run get the data. Now, I would say in future, if I tell you what the data lake is for the benefits of people who doesn't know about data lake. Now, if you go to a normal lake, water in the lake doesn't know what the usage is. Right? It might be to wash your hands, or wash your vehicle, or to drink the water. Water doesn't know what the usage of that water. Idea is that you store your data in a lake so that it can be utilized whenever you need for different needs. So data warehouse is not now that era has kind of gone. I mean, still people are using it, but may not be a very how do you call it, very futuristic approach now. I mean, if I compare lake and data warehouse, I would say data warehouse is like the bottled water. Right, bottled water, where it's ready, you would simply open the bottle and have your water. But data lake is not that. It's not only limited to drinking. You can use it the way you want, but then you need to do transformation before you use it. So again, another future aspect would be, so don't think cloud would be a future aspect. It's a current aspect. I would think people will use multi-cloud. Even now, there are a lot of tools coming in. Those tools have a lot of issues when combining with multiple clouds. So future would be, now we are seeing analytics happens on multiple databases, like Oracle to SQL Server to MongoDB, likewise. Right? So I would say in future, you would see data analytics among multiple clouds as well. So employment opportunities. So where this BI analysis or business analysis would be fall into. So main analysis. So yeah, basically these are the four pillars. Since I'll just run through this, the four areas. We will have the data warehouse analytics, data warehouse manager, business analysis or business intelligence analysis, and the data analysis. Then, so again, different position need different skills. Different skills also in different weightages, right? So you would see B analysis, especially the business analysis, you would need a lot of communication. As I said, you are bridging. Now, when you are saying communication, you need technical communication here. That's what you are looking into, right? Basically, as I said before, you are bridging the gaps. Yeah, right. So this is somewhat. I saw some questions on salaries in Sri Lanka, but let's look at that differently. But in US 2018, I couldn't get the latest data due to this pandemic, and they have not yet released. So these are the salary scales that you would get. Okay, so that would be it from my side. So basically, what I want to tell you is business analytics. Still, you might be having these roles in your organizations, right? But I would say the full value of a business analytics is not yet leveraged, yet to come. More are confined to diagnostic and descriptive analytics, but we need to go beyond that, which is predictive and prescriptive, and also predictive and prescriptive in lot other data sources that you have, such as web, email, chats, and everything. Yeah, so that would be it from my side, Javier.
Dinesh, thank you so much. Again, I think very enlightening, lot of information there, and very, very interesting. Thank you very much, Dinesh. Dinesh, before I let you go, I just want to ask two questions that have come in from you, if I can address this to you directly. So Dinesh, one question is, how is the future, and this question is coming from Exera. Exera sends us this question: how is the future of business analyst profession in a data-driven world? So that's the question, Dinesh.
Okay. So in a data-driven world. So future would be data-driven world, no doubt, right? So in a data-driven world, more and more analysis has to be done, right, with data. So as I said, so in future, we won't see a data scientist. We would see a data scientist team, right? Because you need multiple skills, database algorithms, data mining, process mining. So business analysis need to join this. So he or she would be the person who will be binding this two team together, right? In technical, project manager might be doing the traditional management stuff, but in technically, he or she would be the person who will be binding this team together. So as and we move along, even today you might have one or two data scientists in your organizations, but honestly, I would think you might need data scientist team, right, to get this because you have a lot of data, you have lot of you need a lot of information and to generate, and a lot of things has to be done. So therefore, I would think BA will have a huge future when it comes to data scientist teams.
Thank you, Dinesh. Along the same lines, there is another question from Mark. Again, very similar to this question. And this is with regards to what Mark is asking is, isn't business analyst a dying career? Because what he's saying is that instead of hiring BAs, many organizations are just giving the task to software engineers. What are your thoughts on that?
Okay, yeah, so it depends on the scale that you are working in. Now, if you get a if you get a small project, you might not be able to have a different funds for BA. But I'll tell you some examples. I can't again tell some of the organization's names when we want to bid for projects, right? So when we want to bid for projects, there are technical evaluation and the financial evaluation, right? So let's forget about the financial evaluation. When it comes to technical evaluation, we will ask, right? We will ask, okay, provide us your technical methodology and so on and so forth. Then your team. In that team, we specifically ask who is your project manager, his skill set, and the BA skill set, along with the software engineer, QA, all of this. We specifically ask BA. Right? In medium and large scale organization, you might be correct. For small scale organization and business, you might not need, right? Sometimes in such organizations, data software engineer is the one who collect the requirement, one who develop the software, one who test the software, and he might be also going to the customer place and deploy. I mean, they're different models, but definitely when it comes to medium scale and large scale organizations and projects, you need a BA, right? Where he will gel their team together.
Thank you, Dinesh. Absolutely. Mark, I hope that question was answered. I think it was answered very well. Dr. Subha, if I could also just ask you to chip in or respond in any way you feel on any of these questions. Please, at any time, feel free to do so. Okay, this next question I really want to direct to you, Lasita. This is a question from Tisara, and what Tisara is asking is, he's saying, what are the sectors here in Sri Lanka that use big data in a big way? I know that you did answer this actually to a certain degree in your presentation as well. And what he's asking is, what would be the future? Are there trends to predict what the future would look like in terms of where big data would be required?
Yeah, so definitely there are organizations utilizing heavily on big data. So as like, since we can't name the organizations, so there are organizations related to telecommunication. So even in my speech, I briefly touch base. That's one of the biggest organizations, and even in Sri Lanka, most telecommunication organizations are into big data and analyzing the data of the people who are using it. And also, if you think about services that are offering us to find transportation, right? So these type of services and these type of companies are also heavily looking into big data, where they try to analyze who's trying to find transportation, where are the people located, and where are the riders trying to where are the certain people who are offering vehicles for these people are located. So all of this data is being captured, and there are organizations in Sri Lanka utilizing this data. And I have heard of certain organizations who are working with overseas clients as well, who specialize on satellite related imagery, where they look at certain types of vehicle parking, traffic, those kinds of data as well. And there are organizations doing such analysis as well. And in terms of the future, there is, yeah, this industry is always booming, because as we explained clearly, there is more touch points for data, and more people are generating data, and there'll be more devices also that will enable us to generate more data. So because of that, this is not a dying industry, and it will always be booming in future. I hope that answers.
Absolutely. Thank you, Lasita. Fantastic. I think one question I wanted to ask you as well, Lasita, again, is that how safe is all this data, right? There's so much of personal data on the net. What's the security side of that? And also, Dr. Subha, if I could rope you into this question as well, there's so much of artificial intelligence based applications out there that's using this data, right? So how safe is it, and how should we be concerned as consumers that our data is out there and can be used sometimes not even by human beings? The systems, the machines themselves may use our data for various organizational objectives. So how safe is it?
Yeah, so there were many issues regarding people's privacy, as well as that people's personal data being used for different endeavors. So if you are aware of the news and all of that, there were multiple incidents regarding big organizations where they have leaked privacy information of people, and this has been used for different other purposes. So data is not safe. So again, from a twofold, if I answer this, individuals who are interacting. So today we are data, as Asanka said, right? So because of that, there are many touch points. Even if you go to a place, they might be having security cameras, and that might be capturing data about us. So we cannot avoid it. There is no way for us to avoid it. But there are laws available, laws like GDPR, which is actually regulated in the EU region, which looks heavily at the data privacy of users, right? So there is mandates which govern humans, so that we have the right to be forgotten. Let's say if I want to unsubscribe from a certain service, so these particular laws mandate that none of the data pertaining to me, if I want to remove off from that service, should be kept by them. So there are high penalties for each of these things. So it's good that these laws are coming into place. And because of this, we can assure the privacy of users. And from a cloud standpoint, if I explain this particular the question that you asked, so mainly certain organizations are afraid of moving into the cloud, because of the data that they have. So they have this fear that because we are using a shared tenancy, because we are using shared resources on a cloud environment, there would be issues when we move into a cloud, mostly financial organizations and all. And if you think about PII data, which is like private information, there are again laws in US which govern PII, and cloud providers are also providing different services, machine learning services, which can analyze and extract. So on AWS, there's this popular service called Macy, which will use natural language processing as well as pattern recognition to analyze what are the privacy information of users you are capturing. So even cloud providers, all of these backing services are helping us to find and extract this privacy data so that we can make sure that we don't either retain that data or share that data with third parties.
Thank you, Luster. Dr. Subha, are there any thoughts along the same lines that you would like to share?
No, I think Lasit explained everything very clearly. So I'm agreeing.
All right. Excellent. I'll just move to the next question. And this question,
can I add to what Lasita said?
yes, please, Dinesh.
Yeah. Now, very recently, someone asked from Netanyahu, the Israel Prime Minister, about the security systems. He said, "In this world, no system is secure. In this world, no system is secure. What you can do is you can increase the complexity." Now, so as we know, if you want to increase the complexity, nothing is free. You need to spend some money, funds. So then, being a BA, if I come back to the BA, so it's up to you to think what level of complexity that you can bring in, considering the resources and other factors, right? So as I said, no system is secure. If you want, what we can do is we can increase the complexity to which level. That is the decision that you need to take, depending on your systems and your whatever, right? And considering other parameters. Thanks, Arvind.
So Dinesh, I guess that's also an evolving process, no? So you make it complex, then again, someone breaches or overcomes those security obstacles, then you have to keep on doing constant evolution.
That's why we do auditing, right? We do auditing. That's a part of security systems. We do auditing. There are standard auditing practices for different systems. Healthcare system, we have different auditing system. For financial system, I can see a few financial interested people in the audience as well. They have different governance policies and certificates or whatever. Security systems, you have different levels of security policies, auditing policies. So depending on your domain, you will have to have a different auditing systems. And also you need to look at how you access this auditing data and how you improve this auditing. So what you said is it's absolutely correct. It's not that, okay, we implemented security, then you can wash your hands and go away. It's a continuous process. It's a continuous process.
Understood. Dinesh, there is another question actually from you, from someone from someone called Dinesh as well.
Okay.
So what he says is that he says, does your business analytics course help to become a data engineer? Or does it lead to data engineering? And do you cover Python in your BA program?
Yeah. So definitely. So now if you look at some subjects, okay, if I tell you some subjects, data warehousing, web mining, big data analytics, as Lasta said, BI, right? So those are the common subjects, so which is essential for a data engineer. It covers Python. I assume definitely Python should be covered under big data, since typically it's covered, right? Python is covered under big data. Normally, when it comes to data science, you have R and Python. Those are the two subjects cover. Apart from those, the what do you call languages, we always try to demonstrate the features and concepts through tools, via tools. Right now, I'll tell you from my since I am covering the web mining and data management. So when it comes to web mining, I used to cover web mining from Weka, Orange, Azure, machine learning, from those tools. So likewise, we always it's not that we are not trying to demonstrate the tools here. But that's not the idea. We always try to bring the concepts, teach the concept, and bring those concepts from tools. That's what the whole idea of the when it comes to teaching in this particular course. So we do cover the language as well as some other tools as well.
Thank you, Dinesh. There's a question here about actually on machine learning engineering, and Fazlan asks, does anyone know what the pay for machine learning engineering is in Sri Lanka? Is that something that um, anyone could add some light onto?
I will take it, Davinda. Basically, the skill set is important. The payment is not based on the qualifications you have. So, for an example, answering the next question also, in line with both the questions. So the question was the one that having the first degree in the field of data science and let's go to the higher studies. So it's always like this. So we can see people having file of qualifications is still unable to apply models in the practical problems. Right? So there's no point of you having qualifications if you could not realize a model to solve a problem. In the other hand, also, if you have a couple of years of experience working as a data scientist, still could not explain what you have applied for that problem. What is the theoretical intuition of applying that problem? Why you think this model should be the most suitable and how it works and how it will be interpreted. There's no point of having that experience either. So the answer to those two questions is it's all about how well you can continuously learn and adapt and update yourself. So the more the better the skills that the industry demand is having with you, you will be paid well. If you don't have it, you will not pay well. Because nowadays, industry is not looking for qualifications. It is looking for the people who are capable of doing these things, right? So rather than blindly apply these models on the problems, you can try out different models and see whether which one is having the highest accuracy and bring that, okay, that is the model that is best fitted to this model problem. Instead of doing that, you should be able to develop your own models and explain the reasons of applying them. And most probably, you should be able to convince your clients and the other parties the rather than working on these machine learning models, what these models brings and add the values to the business process. That's very important. So therefore, don't worry about the payment. So whenever you do the big data analytics courses or any other courses, what you should always learn is the concepts behind these models and how it should be applied to solve a real life problem. And the learning Python language is not a goal. Should be it's just a tool and a language that where you can model a particular problem in terms of where a machine can understand, right? So you should not worry about language. You should always, it's just a tool that we use to model all these concepts. So how the knowledge being embedded into a machines and how it can be transferred to these machines. That's what the languages are for. So when you are doing big data analytics or business analytics, you should always think of how to identify problems in the business processes and how you can build solutions using these models and architectures, which is available and discussed under machine learning and data mining concepts. That's the whole purpose of all these courses. And we can find people who have a lot of qualifications, but still unable to apply the models to solve the problems. So I think BDA and the other courses will define from there, that is, we give more practical solutions. We always discuss business use cases and how you can point it out to your problems. And we discuss the business process where you can find the real problem and the causes. And then what models, concepts should be able to solve such problems. We discuss them. And the implementations is happening using any of the language, as Dinesh said. It could be R or Python. Okay. Thank you.
Thank you, Dr. Subha. I think very, very powerful comment there when you mentioned also that it's about the value that you can add. That's what determines your pay, really. The moment you perform in such a way in the industry, I think payment is something that will be recognized. And on the same lines, I think Mark has a question asking whether there is a strong demand for machine learning engineers in Sri Lanka, or any data science related careers. My personal response would be yes, there is quite a high demand, but would any of the experts here would like to share on that, Dinesh or Lasita or Dr. Subha?
Let me go first on that. Okay, if you go back to the data warehouse around 10 years back, right? At that time, we didn't have a good good demand for data warehousing. But now, every organization you need to have data warehouse, right? So you might not see vacancies for machine learning engineers like what you see for developers, software engineers now. I mean, that's true. Let accept that. Now, but we all know that future is on machine learning or data science, right? There's a very I always quote this saying this question is always not a new question, always raised by students. So I have very common say for this saying that there is a common saying. There is a popular saying that though you wake up early, sun won't rise. Though you wake up early, sun won't rise. But it is better we wake up at the time of sunrise, right? So something like that. Okay, though you learn machine learning today, you might not see the thousands and thousands of machine learning vacancies, but it will come. Definitely, it will come. Like the sun is rising. Definitely, machine learning will be there in future. So now, don't wait until that time to learn machine learning or any other this trending topics. At that time, you might be late. Not you might be, you will be late, right? So better you be equipped with these tools now, so that be ready for the future. Being in the technical industry, you know how this is changing, right? In next 1 year, 2 years time, it can change rapidly, right? It can change rapidly. Now, if you look at cloud, right? 5 years ago, we didn't have this much vacancies for cloud, right? ERP systems, right? Look at how some organizations now, again, I can't tell some names, some organizations specifically hiring people for ERP systems nowadays. That market we didn't have in 5 years. Not 5 years, 2 years ago, we didn't have that market. But that has changed rapidly. But now, being seen that has gone up, then you start to learn, my dear, you are late. So I would think you might not have a good demand right now, like what you see for demand for database or for software engineers. But definitely there will be a demand in future. Number two, now why you think about Sri Lanka, right? Now, Sri Lanka is not only Sri Lanka is looking as a software outsourcing place, right? Many organizations I know now have started with machine learning projects. Might be small in scale. I know for a fact that some organization doing very simple classification problem, very simple regression problem, right? But they have started. They have started in Sri Lanka for as a outsourcing for some other clients in outside Sri Lanka, right? So again, to conclude, we might not have a high demand right now, very high demand right now, but don't wait until that demand comes, right? Be ready for that demand. Thank you.
Thank you, Dinesh. Thanks very much. Lasta, would you like to add anything else, or Dr. Subba, or shall I just move on to the next question?
Yeah, so one more thing to add there is, like, I have seen two types of employees when we deal with people in organizations. There are employees who like to do the same repetitive task and expect to do the same thing over the next 5 to 10 years, right? So this is very, very dangerous. If you are expecting that you can do the same thing you are doing today in about 5 to 10 years in future, that is definitely not going to happen. So just to add to what Dinesh said, so you have to be up to date about what is happening in the world, especially if you're in the IT industry. It's not like you can be in a cave and you can do the work that you're being assigned and go ahead and continue. So learning machine learning now is actually going to be beneficial for you in future when the need arises. Yeah.
Thank you, Lasita. Excellent. Yeah. And I think the next two questions, both one from Manoj and another one as well, very interesting points here about changing career. So there is Manoj asking this question: can graduates from other fields like life sciences be eligible to study the business analytics or big data programs? If no, how could such graduates could make a career transition to the field of data science? So interested in getting into data science is not there yet, but would like to make a transition. And the next question is also along the same path. Is a finance graduate, but is it possible to make this career path change? Is the question. How complex is it? So maybe I could direct that question to yourself, Dinesh. Is that okay? And anyone who would like to add on, please feel free.
Yeah. So yeah, okay. So if you look at that slide I showed you about the skill set that you need domain knowledge. You need domain knowledge, an essential skill for a business analysis. So if you have different domains, like I saw some comments like statistics and finance or something. I mean, you're always you don't need to be a IT graduate to be in the data science team or whatever, right? So here, I mean, I personally would love to see different skills of people in a team. As I said, it's a team we are looking into, right? So you need different skills of people where you can have a different perspective to the team. You can bring a different angle to the team, right? You can bring in different aspect to the team, right? So I would think there is no barrier as such. There is no barrier as such, whether it's IT graduate or whatever, right? I mean, end of the day, I think as Dr. Subha previously said, what we need is that people who have the right attitude, right? So that they can achieve this. I mean, it's not certificate that we are looking into, right? I mean, honestly, when we are doing interviews, we never looked at what the qualifications you have. What we are looking for is whether you have the right skill and right attitude to right attitude, right? So we always say that hire for attitude and train for attitude, right? Right. So that's how we looked at. So it's not only the skill set that not skill set, qualification that you have, right? So if you have willing to go into, okay, I have a finance thing. I mean, I know few people who has basic degree in finance. I mean, I know a person who has some degree in social science. Now he's doing well in not in machine learning. He's doing well in data warehouse, right? So I mean, so if you have a social science or whatever the different different qualification in different field, that doesn't stop you to become a data scientist or in this particular area, right? I mean, personally, I would welcome these people rather than seeing traditional IT graduates only, right? I'm not saying we don't need IT graduates, but I would love to see these people as a mix of mixing with others to deliver the goal for the organization.
Thank you, Dinesh. And I think that answers also Devani. It answers your question. So Devani's question.
Indra, shall I add
Yes,
more?
Dr. Subha, please go ahead.
So I think they have to focus on, because they are already equipped with business domain, right? So life science is one of the business domain where AI has emerged from, and where the organs and the biology concepts being discussed. And so many deep neural networks has been, and their operation has defined from. So on the other hand, there are business processes in the biology industry as well. So when it comes to, and even to the financial graduates, so there are banking industry and so many financial institutions practicing the data science and machine learning projects. So they don't need to directly jump to the IT industry as the IT graduates or need to be. What they have to do is to use that domain knowledge as a additional advantage over the others in the as a coming as a business analyst. They might looking into the positions of these industries where they can deliver much of very strong business process analysis compared to the ID graduates or computer science graduate when they do the business analysis, because they don't have such business domain as these people. So you can easily transfer to business analysis, but remember to be in the domain where you are very comfortable from your first graduates. So the financial professions or the life sciences or the social sciences, every industry is now being applying is their own machine learning and data science teams. So you can easily position yourself if you know in addition to the business domain, if you know the vocabulary and the technologies in abstract and the main concepts behind these data science concepts, then you're, I think, comfortable enough and capable enough to be one of the member in there. So the key here is, if you are having a very good business domain backing up in your first degree, then find the industry where you can practice it as the main business process and be there as a business analyst. You will be very comfortable and will be performing well over the others, even they are coming from computer science. That's what I have observed. Yeah, thank you.
Thank you, Dr. Subha.
Yeah, so can I add a few more things, Havindra?
Absolutely, Lasta. Please go ahead.
Yeah. So something that I have seen when people are switching careers is mostly that you feel that you are behind, right? So you see others who are doing the similar things and you want to change your career and you feel that now you're laid back and you feel behind. So some of the mistakes that people do is they want to accelerate the process. So in order to accelerate the process, what do? They will try to find the quickest way that they can learn all of these things, right? So what are the quickest ways that are available? So generally, most cloud providers, they have ready-made services, ready-made things available that people can use, right? And they start using them without having the foundational knowledge, the fundamental knowledge, what is happening behind the scenes, right? And they call themselves as business analysts or maybe a machine learning expert or something like that. But ultimately what they're doing is they're just consuming a set of services developed by others, right? So make sure that you are fundamentally strong. If you're entering into a new industry, bring your domain knowledge, bring your strengths to the game, as well as learn the fundamental things that are there in that new industry, in that new field, so that you are well equipped and so that you can divert into other areas in that same field that you're picking. That's what I wanted to say.
Thank you so much, Lasita. Absolutely. And I think, Nishantan, this goes very much in, I noticed that you've made a comment on as well, that you feel that you're on the right track. Absolutely. That is very true. Also, Deoni, I hope your question is also answered. Deoni is someone who has a lot of experience in software engineering and would like to change to her career to data science. And as a beginning step, she has started her MSc in big data analytics. So absolutely, I think that's the way to go forward. Dinet, we have Dinet from Facebook who sent us this question. And Dinet says, in selection of a bachelor's degree, which is the best choice, data science or computer science degree? So is there any light that could, can I ask that question from Dinesh? Is that something that could be answered? I would think.
I would think Dr. Subha is the good person to ask that question.
Right. Dr. Subha, would you?
So the computer science or the data science? Well, it is based on the curriculum they offer, I would say. If it's the computer science, usually you are getting very good computer science knowledge as well as the mathematics and the statistics knowledge. you are very strong in terms of mathematical foundations and the programming skills and the required analytical skills as well when it comes to statistics. On the other hand, if you have a data science that just covers the basic statistics and teaching couple of Python languages and just computer basic concepts, I would say you go to the computer science degree, because the data science, you cannot do it by just 4 years. You need to have very strong mathematics and statistics skill behind you, and also the very skillful programming knowledge, and where you can model many or program many complex systems. So therefore, a curriculum, irrespective of what is the title of the curriculum, if a curriculum is very strong fundamentals in mathematics, statistics, and computer science, I think that's the curriculum we should always give the priority, because today what we practice as models might not be there in future after 5 years, because quantum computing is coming, and then we'll have quantum computing degrees also. But the person who knows the basics very well can easily extend to those domains. If you don't have that basic skills that require for you to acquire higher knowledge or the complex models, then you're unable to move on from there. So therefore, if I am you, I will not go after a title of a curriculum. I will go after what is the content of that curriculum. So that's my question. So I can see many data science courses and many other courses coming in. You give a chance and see what is the content they being covered. Are they depth enough for you to one day come and appear as a data scientist, and then develop your own models and adapt to the give solutions to the business process. So if it is there in the data science, because if it is comes to the data science, you have to learn a lot, because from the cloud computing to the data visualization, the entire paradigm the course has to cover if they want to cover as data science. So that is a whole lot of theories and the models and the skill set is required. The most of the time, the curriculum I have seen is they just touch these concepts and move on, and do not put sufficient weights on these things. So therefore, when you pick the curriculum, go to the content and see, because I have seen those who have not even heard of data science, if they have very strong computer science and statistics skills, they could capture it very fast than the others. So that's I have experience already. So that's my advice. So I'm not advising you to go and select the title. I'm advising you to go and see the content in the curriculum and see whether it is depth enough for you to develop by yourself after you completing your degree. That's the whole purpose of analyzing a curriculum. Yeah, thank you.
Dr. Subba, what you just mentioned, and thank you for that. Is it also in, there are a few very interesting points that have been raised by both Lakdi and Yasin about some of these free certifications offered by Harvard and MIT, and also Google along data analytics, along that subject domain area. And what you said also, does it apply for those kinds of certifications also?
Yeah, so I have seen many people have a lot of certificates. I was part in some of the interviews, but they lack the knowledge, right? So they lack the knowledge, and when we give a business use case, they are unable to apply the models. So actually, I also take, frankly, many Coursera courses. I usually audit them. I don't have any certificates, but I usually audit them free, using the what trends and the techniques being discussed, and all sort of like per year, like 5 to 6 courses continuously for to update myself. So it's a good practice for the anybody, irrespective of the beginner level or the expertise level, always to do auditing of these Coursera courses and update yourself with the available and state-of-art technologies. I don't think you must always carry your certificates, right? So I don't carry any of the certificates. I think neither of any of these speakers will carry their certificates either. We always discuss with our experience and the accumulated knowledge of getting these courses and doing some practicing these things in the industry. So that's the you can go and take these courses, but if you do not do it well, that's what I mean by not completing the course, but just taking all the labs, because most of the time I see whenever the certificate course there, the GitHub is also having the answers to that, the question in the Coursera course. I have almost seen almost all the courses. I can see the answers also in the GitHub, where, and sometimes the people have maintained their own blogs, so that that's if you have copied from there and submitting, and people can get the certificate also. I'm not saying everybody is doing that, but those are freely available on the internet as well. So it's a good thing that I always advise, don't look for the certificates. You look for and seek for the skills and the knowledge, then you will be safe. So irrespective of whether it's a Google certificates or the IBM certificates or the there's no certificates, if you can answer the questions posed to you at the interview better than the others, you are safe. That's what I have experienced throughout the last few years. Yeah.
Thank you, Dr. Subha. And we're just coming down to the last set of questions. We're going to wind up in just a few minutes. And let me just touch on these two questions. One is from Exera and one is from Mazin. Exera asked the question, how can a traditional IT business analyst become a data or AI related business analyst? And how is that transition possible?
And if you are well aware of the vocabularies and the terms being used by the data science team and their main basics approaches and very basic statistic approaches, you are very good to start with as a business analysis. So the key here is for a business analyst to, from my perspective, they should be ready to always to read and understand where the problems are, where the processes can be improved, where the processes can be optimized, and where the causes and failures are. If it is there, then of course, the business analyst is the key person to communicate and bring this technical value with the technical team to answer this business problem. That's my perspective of BA. And I valued it as the most important role in the data science team, because that is the key of understanding the requirement of the clients, understanding the problems in the business process, because he's the one well listened to the business process. He's the one coming from this business domain. So he understands well about this business problem and its needs. So the technical team, once the problem is identified, the technical team is to give the solutions for this business process and the problem he has bring in, and that solution will take it back by the BA to the client, giving and putting it as a marketing or the selling it to the how to solve that identified problem. I think that's a very interesting and very important role in data science team. So I always encourage, it's not an easy job to. You should have very good eye and you should have a very good analytics skill, not in terms of technical, but you need to have your business domain very strongly, where you can analyze the processes and where you can see the optimizing is possible, where you can see the automation is possible, and where you can improve the decision processes. That's my comment to that question.
Can I just add what Dr. Subha said?
Yes, please.
Yeah. So there is nothing called traditional business analysis. I mean, all are business analysis. Only thing is your environment has changed.
Yeah.
That's the only thing has happened. I mean, correct, Dr. Subha, what she said is like, there's nothing called AI BAs or data science BA. I mean, there is nothing like that. But thing is, the business has shifted into a different paradigm. BA, so his environment has changed. So now he has a broader challenge. Like what Dr. Subha said, you need to listen to what people are saying, and now your solutions, you have multiple solutions. I mean, not multiple solutions, multiple technologies of solution that you have. So there's nothing called traditional BA or AI BA or future BA or nothing like that. BA is BA. His environment has changed and it will evolve as well.
Too close neither.
Yeah.
Thank you. Thank you so much, Dinesh. I just wanted to check if we have time, but I think we are running out of time. Let me just close with one more question, and that is the difference between business analytics and finance analytics, which is a question that has been asked on what the difference is between business analysis and finance analysis. If someone could just touch on that, perhaps I could ask. I wonder whether it's either Dinesh or Dr. Subha who could touch on that.
I would think, so Dr. Subha can correct me, business, so the finance analytics is subdomain of business analytics. I mean, business analytics, I mean, finance is coming under business analytics. So business is everything, right? Of entire organization. I mean, as I understood that question. So when it comes to organizations, people are looking into different aspects now, not only finance, right? Finance might be the driving factor, yes, true. But then people would like to see the HR processes, administrative processes, a lot of other things, right? Finance is one of them. Out of your business processes, finance is one of them. You might have different weightages. It might have very high weightage than to the others, but it's a subdomain for, I mean, from set from business and processes, right? Processes, yeah.
Yeah,
Thank you.
for the I think Dinesh covered it. The financial analytics, I think it's very important, right? So when it comes to the banking industry, the retail industry, supply chain management, everything is connected to the finance. So are there any business organization without a financial processes? Is not there. So I think what you wanted to see is that if you have a background in finance, how you can work as analytics. So think it of like if you are working in the bank or any of these retail organizations. So if you want to improve the supply chain management as the financial analytics, what automations, what intelligence you would like to bring in, that is the task of financial analytics if you want to be in that terms. So we call the person who are involved in these processes of the financial processes or the supply chain management, where you can bring blockchains or where you can automation or intelligence aspects of getting more revenue or more profit to the organizations. So you are working as a business analytics, as basically working with the financial processes. That's my answer. So there is no financial analytics as such, but most of the time you might see these job descriptions because some companies advertise basically then saying financial analytics. They are mainly on the trying to see a person who having the domain experts knowledge or business domain having the financial side. So that's why they might be advertising as financial analytics rather than business analytics, to narrow it down the business domain to the financial sector. Okay, thank you.
Thank you so much, Dr. Subha. And thank you so much, Dinesh and Lasita, for your valuable time. We've spent so much of time together and you've responded to so many questions and also shared a lot of content with us. And, you know, on behalf of IIT, sincerely, very, very grateful for all of that. Just to let everyone who's logged in know that the May intake is already also open at this time, and you can get information by contacting IIT, right? So you can call IIT on 0766 760 760 or log into the website www.iit.ac.lk and get more details, right? I'll give you that number one more time, 0766 760 760. Okay, so with that, I will bring it to the session to an end. And once again, thank you everyone for joining in, and we appreciate your time very much. Have a wonderful evening, and we wish you all the best for the new year that's coming up in a few days' time. Okay, goodbye, everyone, and good night.
Thank you, Havinder. Thank you.